Well, hi, good afternoon. Did you guys see the whale? Yes, that is exciting. I was just saying, that is the closest I've seen a humpback whale to Ketchikan yet. In 20-some years. I'm much older than I look, yeah? So that was really exciting. So there was a beautiful path. We'd seen them for a while away, and they kept a nice straight trajectory, and they came right down by the side of the boat. So that is a good start for our whale watching afternoon. So I'd like to do this presentation now because we're going to go into one of our first areas where we have a really good chance of seeing whales by around about 6:30 this afternoon. So we'll bob out, we'll talk about whales for a little while in here, and then hopefully find some more this afternoon. I also want to mention that after we've gone through our scenic cruising areas tomorrow, as we emerge out into Holcomb Bay about 9 a.m., anywhere between 9 and 10:30 is pretty good whale watching territory too. Yeah? So if you are really keen in seeing whales from the ship, that would be another really good time to get out and see what's going on. So, okay, so this presentation is called Gentle Giants of the North Pacific. As you may have heard me say, I'm actually involved in humpback whale research, so this is my passion project. You know, we all have one, I guess. I've been doing humpback research now, I think I started in the late 90s. I did my graduate degrees, I did my master's and my PhD. And now I teach at a university, and I carry this on as part of my work at the university. So what I'll be talking about today is some of the things we found out, some of the new stuff we're working on. And rather than the whole how big, how long, how old, how many babies, I tend to focus a little bit more on some of the things about humpback whales that maybe you haven't heard of yet, and hopefully present some new information to you. When we're out on the decks, I'll cover that basic natural history, so hopefully answer all those questions. But in the meantime, I would like to introduce you, maybe once more, to the gentle giants of the North Pacific, the humpback whale. Well, of course, we've got lots of different types of whales that we can see in these waters. Marine mammals in general include seals and sea lions. The sea otter is usually sort of adopted by marine mammalogists, even though it isn't truly a marine mammal. A marine mammal is defined by the fact it has blubber, and a sea otter doesn't. So this guy's actually a physiped, in fact. And these two here, our seals and sea lions, are pinnipeds, yeah? And then we have our toothed whales here, and our baleen whales here. I'll be talking more about the tooth side of things, and specifically about orca as we head back down into Victoria towards the end of the cruise. And today what I'll be talking about is our very favorite whale, the humpback whale. When you first see a whale, it tends to be that you see a portion of them. You see a fluke, a tail like this, you see a pectoral fin, maybe you see the blowholes as the whale emerges. And it's not always you get to put the whole whale together. Having said that, these glimpses give us some really interesting insight into the life of humpback whales. And as I say, the more that we're able to use new tools that we have in science today and things to really get an idea into the life of the whale, the more interesting it actually becomes. However, to really understand the behavioral ecology of whales and how they behave within their environment, it's good to put them in context, evolutionary context. Now, I know you say things like evolutionary biology and everybody feels a little sleepy usually, but essentially, if we think of where whales came from, it kind of opens up a little bit more understanding of how they behave. Essentially, if we were to think of the closest living ancestor to a whale in the water, yeah, what would you think is the closest living ancestor left on land? What do you think might be a little bit like them? An elephant's a pretty good idea. Think of a more watery version of an elephant. Rhino, we're on the right lines. Hippos, it's actually hippos, yeah. So they fall within the same clade if we've got any biologists here. Yeah, and they're essentially evolved from animals with hoofs, yeah? And what happened is when the climate changed 60 million years ago, and whales started foraging, basically some of those mammals started foraging on the shoreline. So some of those terrestrial mammals started rooting around on the shoreline for food. As they exploited that potential food, they started to evolve adaptations that would allow them to persist in a marine environment. And so we actually have a mammal that's gone back into a marine system. And if you keep that in mind, then it makes a little bit more sense as you start to understand how whales fit into their environment. And really what you can think about is something like an elk or a caribou, especially with baleen whales. If you take that migratory grazer and put it in a marine setting, it's a pretty good indication of what we have with a whale today. Okay, as I said, there's two types of whales. We have toothed whales and baleen whales, and humpbacks are the 5th largest of the baleen whales. I always tend to mention that when you see a humpback close up for the first time, you tend to think this is something that its mother would love, because, you know, it's not a very charismatic animal. You know, you look at orcas and they're all sleek and black and white and they look like they're made for a Disney movie. And humpbacks are not. They're sort of knobbly and they've got these tubercles all over them and a little hair comes out of the tubercles, so they have a hairy chin. They carry about 1,000 pounds of parasites and they have really bad breath. So if you're downwind of a whale when it exhales, you feel like you're smelling the things they ate for the last 6 months. It's stinky and it's got mucus in. It's like, oh my God, I just got snotted by a whale. It's really not a pleasant experience. Having said that though, as big as they are, you know, when you see them and you start to work with them like I have in the last few years, every time you work with them, you get this new insight into what's going on there. It's pretty interesting. They are basically migratory, as I said. And this becomes really important to something I'll refer back to at the end of the presentation this afternoon. But essentially what we're looking at is a North Pacific population that we divide into stocks. We have one group that heads down to the Rio de Janeiro Islands and the Mexican coastline here. And they tend to come up to the BC waters and even sort of northern Washington, Oregon for their feeding season. Then we have the Southeast Alaska group, and most of those guys head down to Hawaii. And then we also have an Eastern Pacific stock, and they're moving between up here in the Aleutian Peninsula and down here towards Japan and the Philippines. What's really interesting, though, is we saw this year, the connections between all three are really quite strong. These migratory routes that I've just described, usually we would say 90% of the population migrates. They come down to these winter breeding areas each year. This year, we had a really unusual year, and sightings in Hawaiian waters, specifically in Lahaina, where I'm based in the winter months, were down to about 30% of usual. And down here in the Mexican breeding grounds, they were down to about 10% of usual. Now, if you start looking at the number of whales involved, this is like we had 10,000 missing whales this year, and we're still trying to work out what happened. We're suggesting it could have been El Nino influence, but what it is, we actually don't know. So we're in a very interesting scenario at the moment as we watch to see what's happening and how many whales we have in Alaskan waters. And what was really interesting is what we saw in the central and western side of eastern side of the Pacific was also evident in the West Pacific. The Philippines and Japan had about 10 to 20% of their normal numbers of whales. So it's interesting times for whales, and it's kind of interesting to me that we always put out all these facts so confidently until the system changes. So whether it was El Nino or not, we're still waiting to see. Notwithstanding, when whales are in the waters of Alaska, they're really here for one reason, and that's to feed. They are going to fast for the whole of that migration. So they're only going to feed for 6 months of the year, and then the other 6 months of the year, they're going to use those stored energy reserves. So feeding is really intense when they're here. When we see humpback whales, we see this really nice high standing glow. We got a little bit of rainbow going on there, which is super cool. You'll often see them in groups of 3, 4, or 5. These are fishing affiliations, that groups of whales that rejoin every year to feed. When they're feeding in these waters, we can keep track of different whales because of the underside of the fluke that varies like a fingerprint. And so what we see here in Alaska, we see the same whales come back to the same area year after year, and even at the same time of year do they come back to these specific regions. These are very loose affiliations that we see, but the method of feeding is really quite magnificent. What you've really got is something, you know, one of the largest animals in the marine ecosystem feeding on one of the smallest. So it's like you or I trying to feed on house mites or fleas or something like that. So these adaptations that they have are really pretty interesting. The baleen hangs down from the upper jaw. And just in case we've got biologists here, it's very interesting. The reason that they have baleen, not teeth, was the mutation in the toothed whales. And a mutation caused the enamel to stop growing in some whales, and so they lost their teeth. And those whales eventually became the ancestors to what's now the whole of the baleen whale group. So this baleen is an alternative feeding adaptation. It hangs down from the upper jaw, and what the whale does is it corrals its prey together, whether it's small schooling fish or krill. It uses bubbles, it uses body strikes, and basically frightens that food into a nice tight ball. It then dives down underneath, dislocates its jaw, and rushes to the surface. As it rushes to the surface, it takes a gulp that would be around about 15,000 gallons. It takes that water into the mouth and holds it in its extended ventral pleats. If I had ventral pleats, they would be down to my knees, and I don't think they'd be real attractive, it has to be said. What they can do, though, is contract those ventral pleats, push the water out through the baleen, and on the little fringed ends, the food gets caught. And the whale then uses a 2-ton tongue to lick the baleen clean and swallow the food. So it's a pretty amazing feeding adaptation that is derived from what was essentially a single-point mutation. And now we've got this whole group of whales that can exploit different types of food. What's really cool about baleen whales is that we can have blue whales and fin whales and humpback whales and minke whales, and they all feed on slightly different places in the food chain. They maybe feed on slightly different prey or prey at different depths. And so we have this stacked thing called resource partitioning, and it means you can get lots and lots of baleen whales all just hitting slightly different places in the food web, which is kind of neat, and it's one of the reasons we have so many of them. Now, the thing that humpback whales are known for, though, is bubble netting. And what they do there is they form into these fishing groups, and they dive down to about 200 feet maybe. And then they start blowing bubbles. And those bubbles are blown in a big ring. And then the whales circulate on the outside and scream at the fish, so they get terrified and come into this tight ball. And then the bubbles start to rise to the surface. And as they rise to the surface, they expand. And the whales come rushing up through the center of that bubble net. It seems to be a matriarchally led thing. So it's a female, an older female, that leads these groups. And the same group of 12 to 15 whales will arrive in the same area, such as Teneke and Let, at the same time of year. And there'll be a few extras come in and try it out. But that same core group, just like a group of fishing buddies, show up year by year. So it's really interesting association. As I say, it's truly an orchestrated routine. Up they come, catch that fish at the surface, and then before you know it, those 10, 12, 15 whales that you just saw disappear below the surface without a trace. So it's pretty interesting to see. But what you really have to do is enough of me talking about it. I have a video clip, and this is from a BBC documentary I was involved with. And they filmed it underwater and at the surface. So this is what it looks like. If I can get my tech going here. Come on, there. And all these sounds are produced by the whales, as are all those bubbles. That's a lot of fish, huh? Now there's the baleen. And these are the ventral pleats that I was mentioning. And down he goes. That's a big whale, huh? Yeah, last little fish. I'm out of here. This is scary. So feeding like this, the whales will stay in this area right until the winter months. And usually, though not this year, usually in October, November, they'll start this huge migration. We used to say that it was photoperiod response. That means as the day gets shorter is what propels them into migration. And that's typically what it might be. However, as I say, we're beginning to understand that maybe it's a little bit more to do with the availability of food than we really had tuned into. Once they set out from these areas, it's about a 4 to 6 week migration. And one of the main reasons they're actually migrating is this guy right here. Because there is still some food available in Alaska waters in the wintertime. However, the females are about to give birth, and if they were to give birth to their 10 to 12 foot long babies that are very poor swimmers and can't hold their breath, and they're very bright white, so they're easy to spot, they would be perfect prey for transient orca. And so it's the push of predation, it's the fear of predation, we call it a landscape of fear, that pushes the migration on its way, and it's the females that are going to birth their calves in the waters of breeding grounds such as Hawaii that lie beyond the extent of the range of transient orca. We've tied it into temperature, and we say that these breeding grounds lie in waters warmer than 21 degrees. But that is a coincidence and not a cause, and we really think that the cause of the migration is to birth their babies in a safe spot. So the females are coming down, and the males are following in the hope, basically, of mating. And so everybody usually sets off to Hawaiian waters. Once we get down to Hawaii, we see our first whales there in about November time each year. They're coming from all over the Pacific. The majority of Southeast Alaska whales will head to Hawaii, but once they get to Hawaii, they're joined by whales from all over the place. Typically in Hawaiian waters these days, we have around 10,000 to 12,000 whales that use the Hawaiian Islands over the course of the winter months. And one of their very favorite areas are the waters right outside Lahaina. So I know we've got a couple of people from Lahaina here who have experience of this area. It's just amazing. I first stumbled into this at the end of an Alaska trip when we got really cold, and it was September and there were cheap flights to Hawaii. So we thought, oh, let's go down to Hawaii for a bit. And before I knew it, the whales were there too. And this channel of water is amazing. This is Lahaina right here, and that's Lahaina Shores, which I can thoroughly recommend as a place to stay, by the way. And there's the rainbow that sits over town so much. In the Au Channel between the waters of Maui and Lanai, mums and calves accumulate, and as those mums accumulate, the males come in the hope of finding receptive females. Now, interestingly enough, it takes a little bit of coercion, because the female has swam 3,000 miles down to the waters of Hawaii. She's given birth to a 2,000-pound baby. She provides around about 70 gallons of milk a day, and she still has to swim back to the waters of Alaska. So for the mums especially, even though they ovulate, they're not that interested in mating, it has to be said. So what happens is the males have to duke it out for the females that may be available, the females that are there in the year between the years when they have babies. And so we get these huge heat runs where you can get 10 to 12 whales rushing along together, predominantly males. Usually there's a female at the start, but not always. Sometimes it's just the males figuring it out. And they're tearing around all over the place with the hope that eventually they will get to mate. Underwater, though, when you get in the water with these whales, as I'm lucky enough to do as part of my research, it is truly an amazing feeling. I love going in with these big groups because mums and calves notice you, but these big groups, you are just part of the group once you get in. It's pretty interesting. We also are now noticing, where we used to say that these are competitive groups, there are definitely alliances within these groups. And this is a group we encountered in the water. At the surface, it looked to be about 12 animals. We got in the water, and there was definitely 18 different animals in the water. This is a juvenile right here, though, and I just love this picture because he adopted me, and we just swam around together for an hour while all these big whales were, doing their thing around us. So you see these coercions going on. You see two whales form an alliance, and then they'll go off after another male, and they'll hold him down and beat him up a little bit. Nothing too much, just kind of rough him up a little bit. And I think what we think is they're establishing dominance prior to working out who gets to mate with females. The other thing that's going on is males are singing. It's only the males that sing, and we could do another 40 minutes on the song. So here's the 30-second version. They're all singing the same song, they're just at different places in it. And we do think that one whale sings, another whale comes in. And of course, when we were just watching this, we're like, oh, he's singing a love song, and here comes the female. And then we worked out which were males and females, and we've worked out that it's a guy singing, and it's a guy that approaches. So we think now it's actually about forming affiliations. And then these two guys, if they've got a similar song, will kind of form a duo. It's like a guy and a wingman kind of thing, and off they go to find a female. So it's a pretty interesting mating system. The reason that we've got so much conjecture and guesswork in it, though, is we've never seen them mate. So it still is out there, one of the big gets, so we don't quite know how the mating works. We do know that the gestation lasts about 10 months. We know that from whaling days and measuring carcasses that we're taking and whaling that had babies inside of, fetuses inside of them. And so the babies are born, for those females, the babies are born the following year in the waters of Hawaii. This is a female right here, though, and it just is a really good indication of how complex things can get, because this female here, these are her pectoral fins. This is a very female activity, and she'll lie on her back and she'll wave her pectoral fins in the air. And we used to think it was thermoregulation, and she's shunting blood into those fins and waving them around in the air to cool down, because they're so big, metabolically speaking, they produce lots of heat and they get too hot. But now we think now we're kind of working out a little better which are males and females. Now we think that's actually a fairly positive behavior, because if a female does that, a male will stick around. And we only know the males from the females because there's a little lobe on the female on the underneath. I'll be able to show you in some video in a second. Other than that, we have to dart them. We have to do DNA testing. So it's kind of hard to work out which are males and females sometimes. But this, if you're a humpback whale male and a female does this, apparently it seems to be a good sign. We don't know quite what happens next, as I mentioned, but we do know that 10 to 11 months later, we have little calves in our waters. We've never seen a humpback whale give birth, though. So again, we have another big mystery yet to figure out. The first calves we see, this is where my area of research lies, and I'm fairly sure the first calves we see are maybe less than a week old, though. So it seems that the births are happening somewhere close by, but not exactly in those waters. Maybe it's deep, maybe it's at night, maybe it's slightly off the shelf in the deeper waters so that all the placenta and everything would be flushed away. You wouldn't attract sharks into your breeding area. So there could be a couple of those different things going on. Notwithstanding, the moms with calves move into those waters off Lahaina, and that's where they'll stay for about the next 4 to 6 weeks. It's a really fast process of development, though, and it's essential for the health of future generations that Hawaii remains a good place for moms and calves. So that's where our research comes in. This is myself and a couple of the people that helped me. This is Amy and Terry, and these two are photographers right here. And the reason I have such pretty underwater pictures are because of John and Dan Cesare, and they have their own art gallery now in Paia in Maui, where you can see a little bit more of their work. And Amy, Terry, and I collaborated on the Alaska Cruise Companion, and a portion of the money from the Cruise Companion goes to support this research project in Hawaii. So it's one of the big motivations for us to be involved and doing this at the moment. So all in all, we're hoping that the work we do there protects that area so that the next generation of whales get a good start in life. I am also teaching at Cal State Channel Islands, so these are my students. We do a lottery system. We usually have about 80 applications for 10 spots, and then they get to come to spend their spring breaks on Maui. So for the average 21-year-old, they're pretty happy about that, let's face it. A lot of stuff goes on I don't ask about, but they do some really hard work as well, and we've been able to publish some of their findings. We've also been working with the BBC quite a lot. This is Tom Fitz. He came out and did the footage for Life Stories. It was pretty interesting working with him. This is his land camera, and to get underwater, he puts that in this massive housing. And whenever he's in the water, one of us swims alongside just to keep a track of everything. So he and I were in the water, and this mum and calf were in between us. And she came up to the surface, and I moved to the side where I would normally go. And Tom was filming, so he wasn't quite watching. And the mum came up, and she put a peck out like this. I'm like, oh, this doesn't look good. And she went right over to him with the camera, and then she boop, like this, right on the camera. And so I think it was the big camera that he was holding that she didn't like, because she was maybe used to being around people, but she sure wasn't very sure of that camera. So there's a piece that they edited out, which went boop, like this, right on the camera lens. But this guy here, Tom Fitz, is an amazing photographer and a very, very, very skilled free diver. So that was really good. And then they donate to the project and keep us going for a couple more years. Okay, so research in Hawaii, that's what my colleagues think I do, but this is kind of what I really do. Long days on small boats, and I would not complain about it. This is our little boat right there, the trophy boat. And it's a pretty interesting way to spend some time. The calves mature really fast, though, so what we've been really working on is how they change. We've been able to look at the dorsal fin. Can you see the differences in these 3 pictures right here? So what we've noticed is that in utero, the dorsal fin is all wrapped up like this, and then when the calf comes out, the fins start to stiffen. So we were able to take pictures of that, document it against the breathing capacity, and this gives us a little tool to work out how old the calves are, because big mums have big babies and little mums have little babies, so you can't use size. So now we've been able to work out which are the young calves and which are the more mature calves, and that's how I can say fairly surely that they're in our waters from the age of about a week old or less, up to the age of maybe 6 or 8 weeks and not much more at all. By that time, that dorsal fin's straight up, and we don't get an accumulation. It seems to be that's when they migrate. Excuse me. Now, when we started to look at the way the behavior changes with age, that got really interesting. We found out that young calves are much more active, and it's actually the older calves that will sit and rest a lot more, and that was kind of my PhD work. But of course that left a lot of questions to be answered. The next thing we wanted to know was, where were they? If you ask people in Lahaina where mums and calves are, they'll all tell you they're in shallow water. Well, doing all this work, I was convinced that they had moved offshore. So we did some more work, and we now found, and we've been able to quantify exactly where they are, which was a big deal. So now we know who they are and where they are, but what we wanted to know a lot more was about why they have these specific behaviors. Specifically, we've started working on how they develop the ability to dive, and that's led to some really interesting research that we just published this year, actually. So if you've seen calves, one of the things they'll do is they will breach and breach and breach and breach, and maybe the Lahaina people have seen this when those calves go into those breaching sequences. And I should say, I did this presentation last week, and the people who went out on the whale watching trip then were out in the waters around Juneau, and the calf breached apparently 59 times by their boat. So if that happens tomorrow, would you please let me know? So really interesting behavior. Typically on the nursery grounds, mum's not feeding. She's providing 70 gallons of milk a day. So why would this little calf be wasting all that energy that could be partitioned to growth by breaching continually? Well, in my PhD, I kind of put some theories together that this might be to do with the development of a substance called myoglobin. And it was one of those things that you send your stuff off to the reviewers, and they're like, no, 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 Rachel, you can't prove that yet. So we came back and we put together a big sample over the last 5 years now of muscle tissue from stranded animals, no live samples, all whales that have washed up on the beach dead. And we get a sample of their muscle tissue. And we bash it up in some phosphate buffer, and we sonicate it to blast open the cell membranes. And this is what we get. Typically, marine mammals carry a substance called myoglobin in their muscles. And myoglobin is to muscles as hemoglobin is to blood. It's an oxygen carrier. What we found, though, is when we looked at the muscles of our calves, they actually didn't have any myoglobin. It was very, very pale in color, and there was no sign of this myoglobin that's so important as they mature. And the thing with calves is they can't hold their breath very long anyway. Yeah? So they're only diving for about a minute or two. Well, putting all the evidence together, what we've discovered is there is a tie-in between that exercise we see when the calves breach and the production of myoglobin. Because exercise, when you move muscles, releases calcium. It's released exactly the right place in the cell at the right form, and it leads through a cascading biochemical pathway to the production of myoglobin. And so now we have a reason why whales would breach, because those calves will be breaching and breaching and breaching as a form of conditioning so that they can then hold their breath and dive. And that's why a 6-week-old whale can maintain a breath hold for 3 to 4 minutes, which, you know, if you've ever tried, you know, I can push 30 seconds on a good day. You know, it's tough to do. So it really seems that that breaching behavior has a function. We don't know yet how this plays out in adulthood, but as I say, we did actually publish that this year. What we're looking at next is the real function of that resting period. We think that's about growth, but to measure growth, what we've been doing is taking to the air. So I wanted to show you this footage, and this was filmed using a small drone. So we just got permits to do this, and it was really, really exciting. So this is just a snippet of what it looks like from the air. So that's a mom and calf, clearly. And this footage is taken from about 100 feet, just with one of those little drones that you see. The escort whale there, the male, hoping to mate with this female, but it's not the dam to that calf. But you can see how these will work for measuring, can't you? You can just get that gauge of the size. And now we have screeching. So that's where we're going, and it's really quite exciting, I have to say. Well, as you can tell, I couldn't get a little verbose on this, so if you'd like to hear more or read more about our mum and calf work in Hawaii, I was invited to do a column for the New York Times. I was on sabbatical from university, and this was published on the online portion. It's called Scientist at Work, and there's a series of 4 articles there that tell you a lot more about the actual work we're doing there, so feel free to check that out. And this is one of Dan Cessary's beautiful pictures. I just love it because it ties in the mums and calves to the region that we work in that seems to be so important. But what I wanted to finish by talking about is a little bit about the nature of whales. Humpback whales, when you get to know them, are starting to display some really interesting behaviors. This is one that, this particular story here was reported in the waters of Antarctic not so long ago for the first time. And what we've seen happening there is transient orca will come in, and one of the ways they'll get to feed on that little seal right there is they come in and they work together and they start creating a wave on one side. And that makes the iceberg start to rock, and then eventually it rocks so much that the guy making the wave knocks off the seal to the guy sitting on the other side waiting. So they're working in pairs to do this. And you know, the seal's last sanctuary was to sit on the ice, and now the orca have figured out how to get them off the ice. Well, this was being recorded for one of the first times down in Antarctic. And as they were watching, the researchers reported that a humpback whale came right into the midst of it. And just as the calf rolled off the ice, the humpback whale scooped in and picked up the little seal, and he rolled over and put the seal right here on his chest and put his pecs in the air and started whacking the orca. So that's pretty interesting, because now you're saving a different species, which is pretty unusual stuff. And it's not the only report of it. We've also seen this happening. That's actually the picture from the Antarctic of the humpback whale that came in. So we're also seeing this now in Monterey Bay. What happens in Monterey Bay is orca come in, and they go after the gray whale mom and calf pairs, and humpback whales are now coming in and fending off the orca as they attack the gray whale mom and calf pair. So these were 2 juveniles that came in, and they just started ramming the orca, and the mom and calf gray managed to escape and get across the canyon. So these are very unusual behaviors. We don't know why we've never seen it before, but it hasn't been reported. But it may be a numbers issue, you know, a safety in numbers if we get more and more humpback whales, maybe that we're spending more time on the water. But they seem to have this responsive, sympathetic nature, which is really quite interesting. But the main reason that I would say that we should all start being a little bit more pro-whale is finally the poop story. Every good presentation should end with a poop story, I think, yeah? So I talked about the salmon in the trees yesterday, and this story is sort of a marine equivalent. It's whale poop in the water. What happens when whales feed is they're feeding down at 200 feet or more. And down at that depth, they gather up krill or whatever the fish is that they're feeding on down there. And then they come to the surface to breathe. And apparently, it's only when they're breathing that they actually poop. And when they poop or defecate, it's kind of like a hose. It's a pretty major event. There's lots of it, and it's very floaty. It's very buoyant. And it's sort of orangey red in color, and it's very, very rich in iron. And what it does is it basically raises the productivity of all the regions where whales are feeding. So as whale numbers have come back, a lot of people have been worried, especially here in Alaska, that it's going to undermine fish stocks because the whales feed on the same food that supports the fish stocks. What we're actually finding out is that the whales themselves are providing the nutrients to increase the productivity in the food chain so that there's literally more biomass. There's more photosynthesis going on. Iron's typically the limiting factor in photosynthesis in these systems, and the whales are providing it when they poop. So it's kind of like Miracle-Gro into the system. And essentially what it means is that our little spot in Hawaii, where we see the start of our whales' lives, where those first 6 to 8 weeks are spent, those whales then spread out right across the whole of the North Pacific Basin. And everywhere they tuck in as a feeding aggregation, and everywhere you find 10, 12, 15 whales feeding, they are literally ensuring the reliability of their food supply. We now know that humpback whales will swim through immature krill. They won't take immature krill, and they'll come back around when those krill are mature and feed on them then. And then even in the feeding process, they're ensuring their own food supply, and they're maintaining the productivity of the system. So we call that a biological pump, because they're very settled waters here in Alaska, and without these mixing effects, you just wouldn't have the productivity that we see expressed in the massive amount of food that's available in this system. So with their poop, whales are undoubtedly part of a healthy ecosystem. There is costs of contact, and hopefully the work that we're doing in Hawaii is very management oriented. We're trying to track their rates of growth, and the more we understand what's going on down there, the better we can protect these burgeoning whale populations, which will contribute to the health of our truly challenged ocean in years to come. So I just want to finish with one more little video clip, which takes you under the water into the world of whales in Hawaii. So this is part of our stuff from Maui. This little guy will be about 4 to 6 weeks old, no more. And that tells you it's a female. See the little bump right there? Was actually a male whale, and that can work as a visual screen at times. Okay, so all that remains to say, it looks like 6:30 is the kickoff time, 6:30, 6:45, 7:15 as we go through Snow Passage. So I'll hope to see you out on the open decks then. Thanks a lot.